Welcome to today's lesson. So we're looking at solving problems involving quadratic functions. So we're looking at some applications of quadratics in a variety of different ways. So recall that a quadratic function in its vertex form, we can have the y-coordinate that represents the vertex as either a maximum or a minimum. And remember, if the parabola opens up, it's going to be a minimum. If it opens down, it's going to be a maximum. And that all depends on the a value. So if a is less than 0, it's going to open down. And if it's greater than 0, it's going to open up. And we know that the x-coordinate from that vertex also refers to the axis of symmetry, or it lets us know that that's where the vertex occurs when the maximum or minimum happens. So we're going to look for the optimal value when this occurs. Okay, so optimal value is the same as the maximum or minimum. So we looked at that a bit yesterday. And remember that there are a few different ways that we can look for that optimal value or look for that vertex. We can either use completing the square, or we could solve for factoring the trinomial. Okay, so we'll do one of each for this one. So for number 1, we're going to take a look at factoring this simple trinomial. Because there's no value in front of the x squared, we're looking for two numbers that multiply to give us negative 12. Those same two numbers have to add to give us positive 4. There's lots of different ways that you can approach this question. You might want to think about the x method. So we're looking for those two numbers that multiply to give you negative 12. Those same two numbers have to add to give you 4. And when you're thinking about what those numbers have to be, you might think about negative 6 and positive 2, or positive 6 and negative 2. Okay. So really think about your signs for this, okay? You want to make sure that your larger number in this case is your positive one, okay? Because we know that one has to be each, so one has to be positive, one has to be negative in order for the product to be a negative value, but in order for the sum to be positive, the larger one has to be positive. So I can rewrite this as f at x is equal to x plus 6 and x minus 2. And doing this allows me to look for those zeros. So we know that the zeros, or the x-intercepts, there's going to be one at negative 6 and one at positive 2. Remember, we keep the numbers but change the sign. And when we find the zeros, then we can find the axis of symmetry. So what is that vertical line that splits the parabola in half? So the axis of symmetry, remember, in order to find that, we need to add our x-intercepts together. So negative 6 plus 2, and then divide by 2. So we're looking for that halfway point. And you can write it either as just axis of symmetry, or AOS, or you can write it as the equation of a vertical line. Negative 6 plus 2 is negative 4. And negative 4 divided by 2 is negative 2. So the equation of our axis of symmetry is the vertical line x equals negative 2. And once we identify that axis of symmetry, we can substitute the value in for x into our original equation, either the standard version or the factored form version, to solve for the y value, or to solve for that maximum or minimum. So, and again, it doesn't matter which version of the equation you plug it into, whatever one you think will be easiest. Let's go ahead and plug it into our factored form. And remember that f at x is the same as y. So we can write y equals, and then negative 2 plus 6, and then negative 2 take away 2. So y is going to equal positive 4 times negative 4, which is negative 16. So we know now that we have an optimal value of negative 16. So is that optimal value a maximum or a minimum? Well, we know that because the value in front of your x squared is a positive number, that our parabola is going to open up. And if it opens up, then we know that we're going to have a minimum. So we have a minimum value of negative 16, when the x value is negative 2. So this was one of the ways that we explored yesterday to look for finding the maximum value or the optimal value, or finding even the vertex. So these coordinates, or these numbers right here, x is negative 2 and y is negative 16, remember, that's our vertex. So we could write that the vertex of our parabola is at negative 6, negative 16. Oh, sorry, negative 2. I don't know why I said negative 6. Negative 2, negative 16. All right, so another way that we can solve for our optimal value is by completing the square. And we looked at different ways that we can do this, either by keeping it as a fraction, or if you really wanted to, you could convert this into a decimal number. Let's keep it as a fraction just for fun, okay? So remember that the g of x just represents the function, so it's this equation in function notation. You can think about this as being y equals as well, if that's easier for you to wrap your head around. And when we're completing the square and we have a value in front of the x squared, we want to factor that term, or that number, or the coefficient from the first two terms. So I'm going to rewrite this as negative 1/2 x squared, and then I have to think about, what is 2 divided by negative 1/2? Well, when I divide by a fraction, I'm actually multiplying by the reciprocal. So I'm actually multiplying by negative 2 over 1, which is negative 4. So now I know that 2x divided by negative 1/2 is the same as negative 4x. Close that bracket, subtract 9. So once we've done that calculation, we can think about now, what do we do to complete that square? So I'm taking the coefficient in front of my x term. So I'm taking my negative 4, dividing it by 2 first to give us negative 2. And then I'm taking that negative 2 and I'm squaring it to give me 4. So 4 is now going to be the number that I add and subtract inside of my bracket. So it becomes g of x equals negative 1/2 times x squared minus 4x plus 4 minus 4, close the bracket, minus 9. Remember, when we're completing the square, we want to factor the first three terms inside of that bracket. So again, we're looking for the two numbers that multiply to give us 4 and add to give us negative 4. And yesterday we also discovered that if this is always going to be that number when we first took our the coefficient in our x term and divided it by 2. So negative 2 is going to be the number that multiplies to give us 4 and adds to give us negative 4. So we can write this as negative 1/2 bracket x minus 2 squared. Now, in order to get the negative 4 out of the bracket, we have to multiply it by negative 1/2. So negative 4 divided by 2 is going to give us positive 2. And we're subtracting 9. If you need to do that calculation on the side of your paper, you can. So we took negative 4 and we timesed it by negative 1/2. Remember, we can write this as a fraction by putting it over 1. Negative 4 times 1 is positive 4. Positive 4 divided by 2 gives us that 2. Okay. And last but not least, we need to just collect those like terms at the end. So 2 minus 9 is minus 7. So now we can say that we have a vertex at the coordinate negative 2, negative 7. And what does that tell us in terms of the optimal value? Well, we know that our parabola opens down, and because it opens down, we're going to have a maximum amount. So that vertex is going to be the highest point that our parabola reaches. So we have a maximum value of negative 7 when x equals negative 2. And this should be a positive 2. So x is equal to positive 2, because when I take it out of my bracket, it's going to be positive. So make sure you watch that. Okay. So now that we just recapped what we knew from yesterday about looking for the vertex or the optimal value in two different ways, so either putting it into factored form or putting it into vertex form, now we can apply this to some applications of quadratics. So example number 1 says that a projectile is launched from a platform and its height h is in meters is given as a function of elapsed time t in seconds by the equation h equals negative 4.9 t squared plus 196t plus 2. And we want to know what is the maximum height of the projectile and how long does it take the projectile to reach its maximum height. So the first thing that we want to do is we want to think about putting this into vertex form. Okay, because we have a negative 4.9, it's going to be difficult for us to factor this using the methods that we know about the line method. You might remember that from grade 10. And because it's a value not equal to 1 in front of the t squared, we know that we can't just factor it using the simple trinomial method that we did in that previous example. So the easiest method to do here would be to complete the square. So I'm going to take my h equals negative 4.9, and I know that I'm going to factor out that negative 4.9. So whatever the value is in front of your t squared is what we're going to factor out of the first two terms. So negative 4.9 t squared, and then I have to think about what is 196 divided by negative 4.9. And when I use my calculator to work that out, I get negative 40. So I have negative 40t plus 2. So I've just factored out negative 4.9 from the first two terms in this equation. Then I take a look at my coefficient in front of the t term. I'm going to take this number, divide by 2, that gives me negative 20. And then I'm going to take negative 20, square that to give me 400. And that's going to be the number that I add and subtract inside of this bracket. So I have h is equal to negative 4.9 times t squared minus 40t plus 400 minus 400, close the bracket, plus 2. We're going to factor the first three terms. H is equal to negative 4.9. Remember that in first number you've found here, negative 20, will be what we put in the bracket. Negative 20 adds together gives us negative 40, and when I multiply it by itself, it gives me positive 400. In order to take negative 400 out of the bracket, I need to multiply it by negative 4.9. Doing that calculation gives me 1,960, and then I'm going to add 2 to that. So just to simplify those last two terms, I have 1,962. So I can say that I have a vertex. This parabola has a vertex at the coordinate 20, 1,962. So what does this represent? Well, the 20 represents the time, and that's in seconds. And the 1,962 represents the height, and that's measured in meters. So we know that it has a maximum height of 1,962 meters when the time is at 20 seconds. So I can write a therefore statement. Therefore, the maximum height of the projectile is 1,962 meters at 20 seconds. Example number 2. Example number 2 looks at a numeracy question. So we're thinking about how we can rewrite this problem using a quadratic equation. So I know that I have two numbers. The sum of the two numbers is 8. So if I let x represent the first number, And for now, I'm going to let y represent the second number. I'm not going to want to use both of these numbers, but this might help you sort of wrap your head around this question. So the sum of two numbers is 8. So if I take x and I add it to y, I'll get 8. So that's the information that comes just from the first sentence. So I've identified my variables and I've written an equation. Now I want to find what those numbers are. So what is the value for x and what is the value for y? If the square of one number added to 3 times the square of the other is a minimum. Okay, so let's think about that for a moment. So the square of one number, so x squared added to, so plus 3 times the square of the other number, so 3 times y squared. When I do this, this is going to be a minimum value. So what does that mean? Well, it means that my parabola is going to open up. So if I think about trying to figure out these graphically, if I was to plot these on a Cartesian plane, it's going to create, these two numbers would create a parabola shape that opens up. So this is my minimum value right here. Okay, now I don't want two variables. So I want to be able to write an equation that just involves x. So instead of writing x plus y equals 8, I'm going to represent y as a function involving x. So what does that look like? Well, I'm going to take my y and I'm going to isolate it from my first equation because that's the easiest one. So to get y all by itself, I have to move over my x term. So it's going to be 8 minus x. So it's positive on the left-hand side. When I bring it over to the right-hand side, it's going to be a negative value. So now when I rewrite my second equation, then I'm going to say, for now, I'm going to replace my minimum with an f at x. So f at x, so that's my function, is equal to x squared plus 3, and instead of y, I'm going to put 8 minus x squared. So now I have something that if I simplify this, it'll be a parabola. So it'll give me a quadratic equation. Okay, and this is where some of that algebra skills come in handy here. So this is not a form that we know. It's not in vertex form, it's not in standard form, and it's not in factored form. So we're going to FOIL out this bracket 8 minus x squared. Okay, so that's the first thing I'm going to do. I'm just going to clean up this expression. So when I have a bracket and I'm squaring it, I can either think about writing this out twice. So I could write this as 8 minus x times 8 minus x and then use FOIL to solve that. That's one way to do it. Or I could square the first term. So 8 squared is 64. I can square my last term. Negative x squared is positive x squared. And you'll notice I left a space here because now I'm going to multiply my terms together. So it's going to be negative 8x. So 8 times negative x is negative 8x. And I'm times this by 2, which will give me negative 16x. So that's just a quick way when I am multiplying a binomial just to do that trick. So square the first term, square the second term, multiply the terms in the bracket together, and then times it by 2. It works every time, right? If I multiply this out, I get 8 times 8, which is 64, 8 times negative 8, which is negative 8x, negative x times 8, which is negative 8x, and then negative x times negative x, which is positive x squared. You'll see it gives us the exact same thing. So if it's easier for you to actually FOIL it out and show that step, go ahead and do that. Or you can use that trick that I showed you here. Okay, so this is just a little side note. Okay. So now I'm going to take this bracket, this trinomial that I have in the bracket, and multiply every term by 3. So I'm going to have x squared. 3 times 64 is 192. so plus 192. 3 times negative 16 is negative 48, so negative 48x, and 3 times x squared is plus 3x squared. And I'm just going to collect my like terms. So x squared, remember there's no number in front of your x squared, it's an imaginary one. So x squared plus 3x squared is 4x squared, plus 192. Actually, I'm going to rewrite this so that I'm going to put my x term first. So I'm going to have negative 48x plus 192. Now you can either try to factor out the 4 from each of the terms, okay, and then try to factor that leftover trinomial as a simple trinomial, or you can complete the square. Spoiler alert, I tried to do this by factoring out the 4 first, and then looked for two numbers that would then multiply to give me 48, because that's what it ended up being when I divided 192 by 4, and then added to give me negative 12, and no whole number works for that, okay? So it's in this case, you're going to want to complete the square, which is probably 9 times out of 10, probably the most efficient method anyway, okay? So let's factor out the 4 from the first two terms only. So 4 and then x squared, and negative 48 divided by 4 is negative 12x, close the bracket, plus 192. Then we're going to complete the square. So we're taking our negative 12, we're dividing by 2 to give us negative 6, and then we're taking negative 6, we're squaring that to give us 36. So I'm going to take 36, and I'm going to add it and then subtract it inside that bracket. Then I'm going to factor just the first 3 terms. The number that multiplies to give us 36 and adds to give us negative 12 is negative 6 for both. So it's going to be 4 and then x minus 6 squared. 4 times negative 36, if I use my calculator for that, I get negative 144 plus 192. Just clean up those last 2 terms. Negative 144 plus 192 gives us 48. So now we can say that if I was, again, to graph this as a parabola, right, then I could say that the vertex of this parabola would be the coordinate 6, 48. So what does that mean? Well, the 6 is our x value, and the 48 would be the minimum value. Right? So x squared plus 3y squared, 48 is the smallest number that when I substitute any numbers in for x and y, that this will give us, okay? When we also know that x plus y has to equal 8 as well, okay? So if x is 6, well, then we can find out what y is going to be. So we're going to take our value of 6 and substitute it back into this equation. So x is 6, so 8 minus 6 is equal to 2. So now I can say, therefore, the two numbers are 2 and 6. These ones can be trickier because it's not something that we can visualize in terms of a real life example like the projectile one. So it is perfectly fine if you were listening to this and not quite getting it at the first. You're going to practice some of these questions on the worksheet, and we can go over some more questions tomorrow when I'm there as well. Okay. So let's go through 2 more examples, and then you can practice some questions on your own. So example number 3, we have a farmer that has 120 meters of fencing, and he wants to make a rectangular enclosure and then divide it so that we have 3 equal sections at the side of his barn. So maybe he wants to put like pheasants or chickens or something inside of these fences, okay? So we want to know what the dimensions of this rectangular enclosure will yield a maximum area. So we have to think about what information do I know? Well, I know I have a perimeter. This is my perimeter. I have a perimeter of 120 meters. Okay, so that's my perimeter. So if I was to build this, so this is the barn, so I'm just building a fence along this side, that side, that side, and then those 2 middle sections there. So my perimeter or my fencing has to go all along these sections right here. Okay, so that's important to think about. And I also know that I want to maximize the area of this entire large rectangle. Okay, and by doing that, I essentially will maximize the area of the smaller pieces as well. So we know the perimeter of a rectangle deals with length and width, okay? So let's call this entire, this length right here, our length, and then this will be our width, which means that this is also going to be a width. So all 4 of these pieces are going to be the same amount, okay? And we can keep it as W and L if that's what you are familiar with and that's what you want to use, or you can use X and Y, okay, or another letter that you want to use, okay? So if I know that the perimeter, I only have 120 meters of fencing, so the perimeter of this yellow part has to be 120 meters. Now, what is that? So if I was trying to come up with an equation to represent the perimeter of just the yellow section, I would have 1, 2, 3, 4 W's plus L, okay? And I know that the perimeter has to be 120. And so maybe I want to, instead of having 2 letters, a W and an L, maybe I just want to represent it as just W's, okay? So that makes it that's gonna be a lot easier for me to calculate. So instead of writing an equation that uses W and L, I'm gonna rearrange it so that I get L all by itself. So I can express L as W's. So 120 take away 4W will be the value of L. So instead of L, I could write 120 minus 4W. Okay. So now I can write an equation for the area of this rectangle using just W's. So the area of my equation, so normally an area of a rectangle is length times width, but I don't want to use 2 different variables. So I'm just going to use my length, which is 120 minus 4W, times my width, which is just W. So now I have an equation that just uses W. And this now becomes a parabola in factored form, okay? So if you want to change your W's to X's, go ahead and do that. If you want to keep them as W's, that's perfectly fine as well. So when it's in factored form, it's easy for me to find my zeros. And remember, zeros are the same thing as x-intercepts. So if I was to think about my parabola, and I want to think about maybe this is an equation that's going to open up because my value here is positive, so it might look something like this. So my zeros are actually those points right there. So they're the points where the parabola crosses the x-axis. Okay, so that's what I'm looking for. I'm looking for those 2 points because if I know those 2 points, then I can find my axis of symmetry, which is the line that splits my parabola in half. Okay, so to find my zeros, I take my expression, so 120 minus 4W. I'm going to set that equal to 0, and then I'm going to have W equals to 0. Okay, so I'm not figuring out these W's refer to the x-intercepts. They're not going to be the same W that I'm going to have when I find my vertex, okay? So I want you to understand the difference between those. So these are the x-intercepts, but ideally we want to find the formula for my vertex that will give me the coordinates. So I'm looking for what is the width going to be when this parabola has the vertexes of my parabola, so the minimum, okay? Or maybe it's going to be a maximum, okay? It doesn't really matter. All right, so let's keep going. All right, so I'm going to take my 120 and I want to solve minus 4W and I want to get W by itself. So let's make W positive, or the 4W positive, by moving it to the right hand side. Then I'm going to divide both sides by 4, so that's the coefficient in front of the W. 120 divided by 4 is 30. 4 divided by 4 is 1. So I'm left with just W. Okay, so that's going to be one of my x-intercepts. My other x-intercept will be at W equals 0, so at the origin. Okay, so those are my x-intercepts. Now, obviously, this picture is not representative of this situation here, but I just wanted to quickly show you what you're looking for in terms of these are your potential zeros versus the axis of symmetry where the vertex lies. Okay. All right, so now let's find our axis of symmetry. So what is the vertical line, the equation of that vertical line that splits the parabola in half? So I know to find my axis of symmetry, I add my zeros together, so 0 plus 30, and I divide by 2, because I'm looking for that halfway point. And I can either keep it as AOS, or I can express it as an equation of a vertical line. 0 plus 30 is 30, 30 divided by 2 is 15. So when x is equal to 15, that is going to be the point or the line where my parabola gets split in half. And now I can take this information and I can substitute it in to figure out what the maximum area could actually be. Now it doesn't ask me to calculate the maximum area, it just wants me to know what are the dimensions of this, okay? And instead of x, remember I could also say that this could be W, so W equals 15. So that means that the width of my shape, okay, is going to be 15 or 15 meters, okay? So if I know what the width of this shape or this fencing, then I can figure out what the length is, because I already isolated for length over here when I looked at my perimeter. So I don't actually have to take this 15, plug it back into my equation to find out what the maximum area is going to be, because my question just asked me to find the dimensions to produce a maximum area. The solutions that I'm going to post that you'll see online show you what the maximum area is if you wanted to calculate that, but for time and purposes, we'll just stick with what the question asks. So I'm going to take my 120 minus 4W, and I'm going to now, instead of W, I'm going to substitute 15 in its place. So length is equal to 120 minus 4 times 15. 4 times 15 is 60, and 120 take away 60 is 60 meters. So now I can say that, therefore, the dimensions that will maximize the area are 15 meters by 60 meters. And the last example that we'll work on together is one that involves revenue. Okay, so a caterer wants $20 per person for a meal at a graduation party. However, if there are over 40 guests attending, the price per person could be reduced by 25 cents for every extra person over that 40-person limit. So how many guests should attend the party so that the caterer can maximize the revenue? So how many people do they want to have attend this venue so they get the most amount of money possible? Well, how do we calculate revenue? Well, revenue is going to be the number of meals being served, okay, times the cost per meal. Okay. So if I know how many meals are being served and I multiply it by the cost per meal, then I'm going to find out how much money the caterer is going to make. So that's the formula that I have to find. So let's identify a variable. So let's let x represent the number of people or the number of meals over 40. Because I know that for a base amount of 40 meals, it's going to be $20 per person. But how many people over 40 can I have and reduce the cost to maximize my revenue? So let's think about this. So the number of meals, so if I'm starting out with 40 meals, how many extra meals, so if I add that to x, should I think about? So I'm starting with my 40 plus x, so that's going to be the number of meals. And then what happens to the cost? Well, it started out at $20 per meal, but I can reduce the cost by 25 cents per extra meal. So this is going to be the revenue based on this scenario. Now this is an equation of a parabola in factored form. And because it's in factored form, I can identify the zeros by substituting these equations or setting these equations or these factors equal to 0. So 40 plus x is equal to 0, and 20 minus 0.25x is equal to 0. So isolate for x for both of those. So x is going to equal negative 40 for the first one. And I have 20 is equal to 0.25x, so make that x value positive first, and then divide the left and the right hand side by 0.25, or the coefficient in front of the x. 0.25 divided by 0.25 is 1, so we're left with 1x. And 20 divided by 0.25 is 80, so 80 is equal to x. So these are my x-intercepts, or my zeros. Now let's find out where the vertex would be. So we do that by finding the axis of symmetry first. So I'm taking my negative 40, I'm adding it to my 80, and dividing it by 2 to find the halfway point. And I can write that as an equation of a vertical line. Negative 40 plus 80 is 40, and 40 divided by 2 is 20. So the equation of that vertical line is x equals 20. So that's the vertical line that splits the parabola in half. Okay. So I can figure out what my maximum revenue would be. So let's go ahead and do that by substituting the value of x back into my original equation. So let's just for now, let's call our revenue y. So y is equal to 40 plus 20, because that's my value for x, times 20 minus 0.25 times 20, and close that bracket. So I'm going to have 60 times 20 minus 5, or 60 times 15, which gives us 900. So I can now say that the vertex of this parabola, if I was to graph it, would be at the point 2900. Now, what do these numbers mean? Well, the 20 refers to the number of meals greater than 40, or number of meals over 40. And the 900 refers to the maximum revenue. So if I'm having 20 meals over 40, I'm actually serving 60 people, right? So 40 plus 20 is equal to 60. So I'm serving 60 meals. So therefore, if 60 people attend the party, the maximum revenue will be $900. So you're going to get a worksheet now, and I want you to practice some of those questions on the worksheet. I've given you the final answers on the worksheet so you can check to make sure you're doing it correctly. If you are having difficulties getting to that correct answer, I have posted the full solutions on Brightspace, so you can always check those. If you have any questions, we can go over any of those tomorrow when I'm here. And I've also put on 3 questions on Delta Math. One that deals with a question like example 2, and then 2 that are some applications of parabolas like some of the other examples. Okay, so I hope this helps. Again, ask your classmates for help if you need some, or go on to Brightspace and take a look at the solutions, and we can go over anything extra tomorrow as we look at problems involving quadratic functions day 2.